Oh, I do apologize. I thought we started at 10 today, so I thought I was 20 minutes early when I walked through the door just now. And now you've already seen all my slides, so maybe I should just go down. But I apologize to the conveners about that mistake. So I'm here today to introduce what Jerry just talked about, but assessment of lunar resources. So not just utilizing these, but before we use them, we need to figure out where they all are. And I'd like to thank Patrick Binet, who helped as one of the experts in developing this. So in the world of space resources, I think it's easy to split up the types of resources that we're talking about. So there are the things for living and working on the moon. This is what Jerry just covered. But he also mentioned at the end that there's also things that we might want to think about utilizing here on Earth, whether or not it's the technology or actual resources from space. And then there's other things that we might just want to use for space activities. And if you are interested, last month there was published the Handbook of Space Resources, which covers all this stuff in quite a lot of detail. And I think the key thing to keep in mind is when we talk about a resource, we often frame it as having a use. And so here are just 3 examples of lunar resources where we can say things like propellant would be used for transportation, or the metals that we find would be used to build habitats. And those are kind of something just to keep in your mind when you think about what is a resource or what isn't a resource. And I think in regard to this session, what we want to do is think about the need to minimize our impact on the lunar environment, especially in a negative way. If you look at what we do on Earth, there's lots of negative consequences quite often to the way that we use resources. And then we need to think about how do we utilize them in a safe and a sustainable way. So throughout this session, people are going to bring up these ideas. So I just put them in your mind right now. When it comes to the moon, this is sort of the image that everybody knows. You can look up and you can see something very similar to this in the night sky. The dark areas are called mare, they're basalt flows. The lighter areas are called highlands. These are older materials. They've been impacted a lot by meteorites, micrometeorites, and they've had a lot of space weathering. If you look at, let's say, an Apollo 11 image, you might question what kind of resources are actually here. This looks like a barren wasteland of rocks and dust. And there's actually quite a lot of interesting stuff in that rock and dust. Metals, rare earth elements, organics, hydrogen-bearing things, oxides, things that we can use through the technologies that Jerry just talked about. And lots of work is ongoing in developing technologies that actually make these usable. And if you're wondering, how do we know all this stuff is there? It comes down to what we did 50 years ago. We sent landers, human or robotic, and we brought back samples. And we have analyzed those extensively here on Earth with all kinds of different scientific tests. And we know quite a bit about most of those dots. Now what I want to highlight here is that you see, okay, we have sampled the mare and we have sampled the highlands. You have dots in the dark areas, you have dots in the light areas. But if you look at this figure on the right that was very popular on social media last year, it's 200,000 color photographs taken over one night, stitched together, where then the authors changed the saturation to make the colors more visible to our eye. And what you notice straight away is that, let's say, this dark area here doesn't really look like that dark area over there. There's a different color. And what that comes down to is differences in the minerals, in the rocks, and the soils at the surface right there that are reflecting the electromagnetic radiation that went into this camera. And what's also interesting, if you think about these 2 areas, and you then go to what we call geologic maps, which is the same thing that we use on Earth to distinguish different geologic rock units that contain different minerals, you can see that these 2 are the same color in terms of how they are categorized for their geology. And you can see there's quite a lot of detail. What you notice, there's lots of colors designating the different impact craters, and then lots of this pink stuff designating the mare. What's interesting, though, is when you look closer at this, now this is a zoom around some of the Apollo sites, 14, 11, you see a lot of detail. And if you read the legend over here, you see that we have some information. But I would pose the question, what's missing? And I would say, in particular, it's quantitative data and uncertainty, particularly about the mineralogy, whether or not it's silicates, oxides, sulfides, interesting things from a resource perspective, differences in the soils, in the clays, what they contain. We know nothing about what the solar winds have implanted, which Mikesell talked about as a very important component of the system of the moon and the Earth. We don't really know what's in the water ice or the cold trap volatiles. And what we also lack is just high resolution ages of the rocks and the soils. So these colors over here are actually indicating different ages. But if you compare that to, let's say, the geologic timescale on Earth, the moon's geologic timescale is actually not very detailed. So we've been working for a long time now. This is data from the Clementine mission in the late 90s to try to put numbers on these things. And so this is just an example of iron oxide collected from orbit. 1 kilometer by 1 kilometer is the pixel size of this image. And if you wrap it onto a sphere, what you notice is that we're lacking lots of information at the poles, which is important because the next missions are all going to the poles. And most of the way that we get this information is through spectroscopy. Different types of spectroscopy that tell us different information, but really just about what's at the surface, because this is where the EM radiation that's either from an active sensor or a passive sensor is coming. I thought I'd just show this. So it's Chang'e 2 data from more recently, 2019. Still iron oxide and now titanium oxide, and we're at 200 meters by 200 meters pixel size. Okay. And now we have weight percent. So where are we regarding lunar exploration? We're still in this destination reconnaissance and resource phase. NASA's sending Prime 1 and Viper. I would argue that to get to a resource utilization phase, we need to map these at the mining scale, which is the meter scale, really. And so we need more orbital missions. We have some that are coming online, like ShadowCam. We need subsurface mapping, which people are calling selenophysics, the equivalent of geophysics on Earth. And we need more sampling. And this is just quickly to show on Earth, we often take lots of different geophysical data sets of surface features, combine those with 3D geophysics, and we make then some 3D model of a reserve under the ground. And so the last thing I'll point out is we also need to keep in mind accessibility and economic viability when we talk about lunar resources. This is just an example of the South Pole, where the authors have taken sunlight, communication availability, and the terrain, the topography, and tried to characterize things based on this sort of qualitative metric. And you see a lot of it is gray, which is easy to traverse, but you have poor comms and you have poor recharge. So even if there's resources there, does it mean that they're accessible? And does it mean that we can use them? Those are things that we still need to keep in mind. And then lastly, we need to keep in mind this idea of a resource versus a reserve. And I take this from a colleague at Colorado School of Mines. But a resource is what we've been talking about. This is just an occurrence or a concentration of some material. The reserve is the actual economically mineable part. And on Earth, we often use different models. This is one example where we talk about mineral resources as being inferred, indicated, or measured, and reserves as being probable or proved. And it's very easy. There's a direct relationship. So inferred resources, we think it's there. Indicated resources, we know it's there. Measured resources, we know exactly how much is there. And then we get into this probable reserve where we think we know how we can get it. And a proved reserve is we know exactly how we can get it. And for lunar resources, depending on the resource, we're still sort of in these top three. And there's a lot of work that needs to be done to get us to here. And this is important because financial institutions that are going to back private companies want to be in this reserve category when you're trying to get a loan from them. So with that, I'll end. Thank you again. I apologize for missing my scheduled time.